Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.3, day 1, entitled Algebraic Expressions. And this is a long section. It's got a lot of detail, but today we're going to talk about basically the first four. We're going to add and subtract polynomials, we're going to multiply them, and we're going to talk about some of the special product formulas that helps to set up the factoring. We're not really going to get into a lot of the factoring today. We're just going to get into taking out a GCF as the first step of factoring today. We'll save most of the factoring for tomorrow. Okay, this chart here just is to refresh your memory about the different types of polynomials we have. If we have just one term, it's called a monomial. 2 is a binomial. 3 is a trinomial. Anything beyond that with 4 terms is called a polynomial. And when we add and subtract polynomials, we have to combine like terms. And remember that a like term has to have the same variable with the same power. That's what makes like terms like terms. So x to the 7th and x to the 6th are not the same like terms. So in example 1 here, they just want us to add and subtract these polynomials. So for part A, adding is pretty much just combining like terms. I have an x to the 3rd and an x to the 3rd. So I have 2 x to the 3rds. And then I have a negative 6x squared and then a 5x squared. So negative 6 plus 5 is going to be a negative 1x squared or negative x squared. Then I'm going to have a 2x and a negative 7x. So that's going to be a minus 5x. And then the little plus 4, he's just my constant. That's all by himself, so he just gets added on at the end. There you go. For subtracting, we're finding the difference. Students tend to forget that they have to think of the subtraction as applying to every single term in a polynomial that comes after the subtraction. So if you want to rewrite it as adding and then changing all the signs, you can. So we'd have x to the 3rd minus 6x squared plus 2x plus 4. Then, if we distribute that negative, or that negative 1 to everything, we'd have minus x to the 3rd minus 5x squared plus 7x. And then it's a problem just like part A. You're going to go through and you're going to find your like terms. Now I have an x to the 3rd and I have an x to the 3rd, but one is positive and one is negative, so they're going to cancel each other out. And then I've got a negative 6x squared and a negative 5x squared, so that's negative 11x squared. I have a 2x and a 7x, so that's going to be a 9x. And then again, I have a little constant, plus 4. So that's just coincidence that for both of these problems, there was a little plus 4 added on at the end. That's not some secret thing I'm not telling you about. Okay? When we multiply algebraic expressions or multiply polynomials, it's basically just using distribution. So it's double or triple or quadruple distribution, repeated distribution. Now there's two ways that you could technically do this problem. For example 3, we have a binomial times a trinomial. And the first method is to do this whole problem horizontally, which is probably what you're most familiar with. It's where you take the 2x and you distribute it to every single term in the second set of parentheses. And then you take the 3 and you distribute it to every single term in the parentheses. So it's kind of like drawing in those little rainbows again. So if you did that, you would get 2x to the 3rd minus 10x squared plus 8x. Then you would get 3x squared minus 15x plus 12. So you just write it out in a big horizontal line. Then you go through and you combine your like terms just like we did in the previous example. So I only have the one x to the 3rd term, so I have 2x to the 3rd. My x squareds, I have a 10x squared, negative 10x squared, and a 3x squared, so that's going to be minus 7x squared. I have an 8x and a negative 15x. So that's going to be minus 7x. And then I have a little plus 12 at the end. Now the other way to do this problem is instead of doing it horizontally, we can do it vertically. So you would take your first, well, not your first, I guess, your longest polynomial, x squared minus 5x plus 4. Put that in the top. And then your other polynomial was the 2x plus 3. Put that in the bottom. And you're going to set it up like you kind of set up problems when you were in elementary school and you were first learning how to multiply. So you're going to take the 3 and you're going to multiply it by the 4 and get a 12. 3 times the negative 5x, that's negative 15x. I'm going to call this a positive 12 because it is a positive number. And then you take the 3 times the x squared, so you have 3x squared. And then you put a little placeholder here. Okay, so it's a positive 0, and 0 is considered positive. Then you take the 2x times every term in the polynomial above it, one at a time, diagonally. So you're going to do 8x squared, I'm sorry, just 8x. And then you'll have the 2x times the negative 5x, so that's going to be the negative 10x squared. And this is a positive 8x, I'm going to put a little plus there. Notice how the x's are lining up and the x squareds are lining up. So now I have the 2x times the x squared, so that'll be a 2x to the third out front. So now I have all my like terms lined up in columns. So that's the nice thing about doing it this way. So now I have 2x to the third, and then I can have negative 7x squared minus 7x plus 12. So you just add down the columns with like terms, just like you did for traditional long multiplication. So this is more of a vertical method for multiplying polynomials. And there are some special product formulas. These we focus on not so much in the multiplication aspect, but I think that they're super duper helpful when we start factoring. But they can be used forwards and backwards. So we have the sum and product of the same term. So that's when you're multiplying two terms where one's a sum and one's a product. This is also known as a difference of two squares. And then when we have a term that is being squared, remember we have to rewrite it twice. You have to write the parentheses twice and then distribute. And you will get this. That's a square of a sum. Sometimes it's also called a perfect square trinomial. Same thing for part B. This is the square of a difference. It's also another perfect square trinomial. And then 4 and 5, these might be a little less familiar to you. This is the sum of, or the product of a cube, and then the difference. So you have, I'm saying it wrong, you have a sum that you are cubing and then a difference that you are cubing. I guess that's the most straightforward way to describe that. So an example 4 here, they want us to find the product. And this was just like on the previous page in that little table. When you have something that's raised to a certain power, when you have a binomial raised to a certain power, you have to rewrite it that many times. So this is the quantity x squared minus 2 multiplied by itself 3 times. So if we had x to the third, we'd have x and x and x. Well, now we just have x squared minus 2 to the third. So we need x squared minus 2, x squared minus 2, x squared minus 2. Now when you are multiplying this though, take the first two binomials and multiply them out. So you can FOIL or double distribute. So you're going to get x to the fourth, and then you'll have a negative 2x squared and another negative 2x squared when you do this part and then this part, your outers and your inners. So I'm going to combine those like terms together as I'm distributing. And then you'll have your negative 2 times your negative 2, so that's a positive 4. So you just made that product of two binomials into a trinomial now. And that is what we have to multiply by this other binomial. So here you do want to do the repeated distribution. So you're going to have x to the fourth times x squared, so that'll be x to the sixth. And then x to the fourth times a negative 2 is negative 2x to the fourth. And then you're going to multiply the negative 4x squared by both of those terms. So you'll have the negative 4x to the fourth, and then you'll have a plus 8x squared. Then you take the 4 and you multiply it by both of the terms in the last binomial. So you have 4x squared minus 8. And then you go through and you combine your like terms. So I don't have any other x to the sixths, so I'll just leave that as it is. I have minus 6x to the fourth now. And then I have my x squareds, so I have 12x squared minus 8. So just do the distribution one step at a time. Pick two terms and distribute, and then take that product and distribute it to your other term, and then combine your like terms. Okay, last part for today is going to be factoring out a greatest common factor. So you should be fairly familiar with this. You should be able to look at three terms like we have here in example A and be able to identify what they have in common. What's the biggest number and what's the highest exponent that we can take out of each term. Well, I've got an 8 and a 6 and a 2. So the most I can take out of all of those is a 2. For my x's, I have an x to the fourth, x to the third, and an x. Now this guy is the smallest right here. He's just x to the first. So really, that's the most I can take away. And that's kind of the trick. When you're looking for a GCF, you take out the smallest exponent. And for my y's, I have a y squared and a y to the third and a y to the fourth. Well, y squared is my smallest, so that's the most I can take out from every single term. So the 2x y squared, that's my GCF. Now my leftovers, I like to call them, are going to go in the parentheses. So what you're doing here is you're dividing the coefficients out front and you're subtracting the exponents. So 8 divided by 2 is 4. I'll have x to the 4 minus 1 is 3. And then the y squareds are going to cancel. Y squared and y squared, 2 minus 2 is 0. And then I'll have plus 6 divided by 2 is 3. X to the third and x to the first will get me x squared. 3 minus 1 is 2. And then I'll have y to the third and y squared. So that's going to get me a y. 3 minus 2 is 1. Minus 2 divided by the 2 in the GCF, that's just 1. X and x, if I have x to the first and x to the first, they cancel. And I have y to the fourth and y to the second, so 4 minus 2 is y squared. There, I'm done. Now part B, you have to look at carefully. It's already semi-factored for you. And if you look at your terms, if you look at this term here, and then this term here, they're kind of separated by that subtraction sign, you should notice something that they have in common. They have this x minus 3 and this x minus 3 in common. That is their GCF. So I'm going to take out an x minus 3 from both of them. And then my leftovers are going to go in the parentheses. Now my leftovers are going to be the 2x plus 4 from the first set of parentheses, or I'm sorry, from the first group of terms, and then the minus 5. So I got a little extra space here. Let me get rid of that. And now the only thing left to do is in this parentheses here where I have my little leftovers, I can combine some like terms together. So this really gets simplified down into x minus 3, which was my GCF, so that's why he stays out front. And then I have the 2x minus 1. So that might seem a little bit familiar to you. When we do factoring by grouping, that's kind of what we look for. We look for stuff in the parentheses that matches, and then we pull that out as a GCF. So this is kind of like a grouping problem, except we were able to combine our like terms after we had our leftovers together. So here's your practice set of problems for this evening. A lot of it should be pretty quick because it's adding and subtracting and multiplying and dividing. There is a little bit of the factoring in there though with the GCF, so definitely practice that because that's a skill that students tend to struggle with. So if you do have issues, come on in and see me before school.